Hi everybody, my name is Kevin Martin again, and I will be presenting our Project 3 linear programming for Team 7. Some real exciting stuff, so we'll go ahead and get started here. Our business problem was a company you might be familiar with. They work here in Conway, they make school supplies, real busy during the summer, and they manufacture these mainly desks and chairs and pretty much anything you can think of that goes into a school. But they have a huge warehouse if you haven't seen it. But anyway, we went ahead and made this problem that they have 5 machines they use for production. These machines can make both desks and they can make chairs. But some machines are better at making desks. They can make more desks than chairs, and some machines can make more chairs than desks in a given hour. And they also have different max machine hours that they can run. So they can only run for so many hours. And so these are going to basically be serve as our constraints. And aside from having different machine hours, different rates for making desks and chairs, they also have different contribution margins. And that is what our max formula up here represents. So again, for every desk that we make, we get a contribution margin of profit margin of $50, and for every chair that we make, we get a contribution margin of $40. So we want to know the optimal mix. How many chairs do we make? How many desks do we make, given the machine hours that we have and the total number of machines given their rates? So in order to do this, we went ahead and mapped out a little table here showing all of the machines' rates. They can make, in a given hour, they can make 5 desks, and in the given hour, they can make 4 chairs. Now that has to be less than or equal to the max number of machine hours they can run, which would be 350 hours, 460 hours for machine 2, so on and so forth. So what we basically did is we left these cells blank. These were our decision variables. And we pretty much multiplied this is how we set up the formulas for Solver to look at to determine what our objective contribution is going to be. This is our objective cell that we used. And this is what we wanted to maximize that contribution margin at $3,500. So after we ran Solver, we actually got a few results here. We're going to go over those. So we did get the max value. Originally it was 0, now it's $3,500. And it says for our decision variables, we should make 30 desks and 50 chairs. You can see that highlighted here. And going further, you can see that it has our max hours listed, our max machine hours given here. And since we set these up through formulas, it'll tell us how long we need to run those machine hours, or how long we need to run the machines for to get the desired results we need. And basically the difference between the max amount of hours they can run and the total we're going to run them to get our max contribution here, our profit contribution, is our slack, which is 40, 70, 100. So that is what we can work with, or how long extra we could run these machines if we wanted to. So going over to the sensitivity report that Solver gave us, we can find that here's our decision variables. They wanted the 30 desks, 50 chairs. And of course, we can't reduce costs because they're maxed. So, I mean, we're going to get 0 values here. Another thing to look at, though, is that our shadow prices, we did get some values here for listing. Basically, we have our max here, our max machine hours. If we chose to run this machine, this is machine 1, its max value, if we could run it for 351 hours, that would increase our contribution margin by 10. So our objective cell. So $3,510 is what we would get if we were able to increase if this machine could run for an extra hour, so one more unit. And I think that is very interesting, and it's very helpful to we're making decisions. We can also see that it has to be within this allowable increase. So it can only increase by 15 units before this is no longer true. And we have to rerun solver. So if I can do it another hour, I can do it another 10 hours if I got a new machine per se or whatever. But I couldn't do it for 16 hours because then I would not see that 10 unit increase in our contribution margin. So we'll go over to our limits report. Nothing shocking here because you can see that we ran it for the max. So of course our lower limit is going to be 0 because we don't allow negative values in there as well. And our upper limit is 30 and 50 because again, we ran it for the max. So something interesting did happen though. If we go back to project 3, we can see that we got a different value for our decision variables. And I'm really hoping you guys can help us figure that out because I sure can't, and I don't know why. We put in the exact same amount, exact same information here, all of our constraints, our same formula for max. And, we even got the same max contribution of $3,500. So I just can't figure that out. And the weirdest thing is if you look at what it gave us 18.57143 and 64.28571. If you go up here to our graph here where we show you the feasible region, you can see that if we look at, it's about 18 for our X value, which is where these are intersecting. And it's just above 60, I think it's 64 for our Y value. And I'm sure that it's this point right here. So it's saying that our optimal point is up here, whereas solver told us it was down here. And that was very interesting. I hope you guys can shed some light on that. But we did actually, graph our intercepts for our constraint formulas, and we determined this was our feasible region because they all have to be less than the max machine hours. They have to be ran less than the max machine hours, so it was trapped down here. And we also wanted to show you guys something pretty neat that we were able to find. And it is this formula here that Excel has that can find your intercepts for 2 given algebraic problems. So we could set these equal to each other and we could solve them and get the same answer, and that's great. But the way you have to go about entering this is pretty strange. But if I wanted to use this to get, and this is what we did, if you can see up here, we actually did find 3050 by taking our machine 1, which was series 1 in this case, and I believe that is our blue line here. This dark blue line is machine 1. This orange line here is machine 4. And we took machine 1's constraint formula and we took machine 4's constraint formula. We listed them down here. And I'll show you guys something pretty neat that we found is if you say equals matrix multiverse is what this stands for. And then you enter the array. I'm sorry, let me try this one more time. You have to highlight, this is important, 2 cells. You have to highlight 2 cells before you get into doing this formula. So again, matrix or our matrix multi, okay, MMULT, they're perfect. And what you do from here is then you go ahead and enter your matrix inverse here. And for our first array, we'll choose these 2 variables here. And then for the second array, we're going to choose our max values here, our max machine hours. And we'll close that parentheses. Now this is the other important part. You can't just hit enter for this formula. You have to hold down Control, hold down Shift, and you have to hit enter. And you'll see that you get 3050 for your values. So we hope you guys found that, somewhat interesting. And we look forward to talking to you guys on our next video. Please give us some feedback and let us know how we did. Thank you so much. Have a good day.